سيداتي وسادتي الأفاضل، السلام عليكم ورحمة الله وبركاته. باسم الجامعة التقنية الجنوبية والكلية التقنية الهندسية في البصرة نرحب بكم مع حفظ العناوين والألقاب بالورشة التدريبية الخاصة أو الموسومة Critical Thinking and the Conduct of Engineering Research. الورشة تقدم من قبل الدكتور مايكل ماثيوز من Senior Associate Dean بجامعة ساوث كارولينا. المودريتر لهذه الجلسة هو أحد أساتذة الكلية التقنية الهندسية طالب الدكتوراه في جامعة ساوث كارولينا ضمن برنامج الابتعاث في اللجنة العليا لتطوير التعليم في العراق في اختصاص هندسة كهرباء، الدكتور حيدر المختار، وهو حصل على شهادة الماجستير في الإدارة الهندسية وأكمل دراسة الدكتوراه في الشهر السابق في اختصاص الإلكتريكال انجينيرينج. الدكتور ماثيو هو لديه ما يقارب 170 ورقة بحثية منشورة محليا وعالميا، وصاحب الفند $5 مليون لعمل به على مواضيع مختلفة بالجانب البحثي التطبيقي، وأيضا لديه ما يقارب يعني المؤلفات وأيضا نشاطات أخرى متعلقة بموضوع Critical Thinking and the Conduct of Engineering Research، وهو مصمم لهذا الكورس التدريبي الذي يعطى بالجراجويت سكول في الساوث كارولينا يونيفرسيتي. فأنا باسم الجامعة التقنية مدير مركز تعليم مستمر ماهر طالب عبد الزهرة أكرر ترحيبي بجنابكم الكريم مع حفظ العناوين والألقاب السيد عميد الكلية التقنية الهندسية في البصرة الأستاذ المساعد دكتور عدنان عبد الله عتيق أيضا موجود معنا في هذه الجلسة، والأساتذة الكرام. دكتور حيدر, I just wanted to welcome Dr. Michael Matthew for today and his presentation. Dr. Michael, it's our pleasure to have you in this webinar, and it's much appreciated from your side to strengthen our skills, and this is very beneficial topic for our faculty and researchers in the university. On the behalf of Southern Technical University faculty, students and staff, we are sending to you our warm greetings and welcome for this online webinar, and all guests from different Iraqi universities, I believe they will get a benefit from this distinguished webinar. Thank you, Dr. Haider.
Thank you very much. You are more than professional.
Thank you, Doctor. Thank you so much.
So he did a lot for me. احتاج انه راح اسوي سويتش للغة الانجليزية مجرد سطر واحد الدكتور ماثيو، وبعده هو راح يستلم.
اوكي.
اللي البنفيت يعني اللي يسأل انه شنو البنفيت من هاي الليكتشرز، الاوبجكت to enable you to use and apply critical thinking model for your research. This is the big picture. أنا متطلع من هاي الفائدة من المحاضرة. Let me say with that إنه راح يشرح لي critical thinking بهذا الموضوع. هو مصمم أقدر أقول أفضل كورسين أخذتهن أنا ساعدني كباحث. With that, I'm going to switch to English. With that, I am asking you give your full attention to Dr. Matthew and help me and welcome him in this webinar. Dr. Matthew, the microphone is yours. Can you hear me, please?
I can hear you.
Yes.
Very good. I would like to say greetings from the University of South Carolina. Thank you for this very gracious invitation to speak to you about critical thinking. I'm very honored. I am glad that Haider has asked me to do this. He is a very good student, and he has been a great source of encouragement to me in these lectures and in the things that I am trying to accomplish. At this time, let me share my lecture slides with you. Haider, are those slides now clear?
Yes, it is perfect, Professor.
Very good. Thank you. So, thank you for the introduction. For today's lecture, I want to follow the model of critical thinking that I have been teaching. So, the purpose of my teaching is to promote a model of critical thinking because I believe it is valuable to the process of research and writing papers for publication. And my objective in speaking today is to enable you, this audience, to use and apply this critical thinking model for yourselves, especially for writing of papers. The information that I want to show you is the critical thinking model itself and the specific ways in which I use it to teach writing of research papers. There are some key concepts that I want you to learn as we go through. First, a definition of critical thinking, the elements of thought for critical thinking, and intellectual standards that should be true for us all. These are universal intellectual standards. The viewpoint from which I am delivering this lecture is my own. I am an experienced engineering professor. My specialty is chemical engineering, but I teach students from all disciplines. I have worked with many students over the years to write papers. We have had successes. We have had failures. I have learned from both success and failure, and I hope to relay to you how to be more successful than I was when I was a new and inexperienced writer. Let me begin with an analogy. Hyder is clearly a very intelligent person. All of the students that come to our university to do research are very intelligent. They make good grades. Why do we have to teach them to think? Why even talk about this? Well, consider this. Let me ask you to think just for a minute. Think and answer for yourself. Have you ever played a game of football? In the United States, we call it soccer, but football. Have you ever played a game of football? Let me ask this. Have you ever played football for a highly skilled team? Have you ever played football where the objective was to win the games for your league? Let me ask this. Is football your occupation now? Is football how you make your living? I will answer these questions for myself. I have played a game of football. When I was a university student, I took a course, and I learned how to dribble the ball with my right foot, my left foot, how to move, how to pass, how to receive a pass. I learned the rules of the game. But I never played football for a highly skilled team. I have done other activities for a highly skilled team, but I never played football for a highly skilled team. And certainly, football is not my occupation. Now, why did I never play for a highly skilled team? Well, first, I'm not a very good athlete, but more important, I never truly learned how to play football. There are rules. There is strategy. There is practice and practice and practice and practice to play football. I must learn to listen to my coach. I must learn to watch my teammates and their position on the field. I must learn to study my opponent and how they do. And for every game, I would develop a strategy for every game. So we have students who have been thinking all of their lives. Their minds work all the time, but they have not necessarily practiced to be highly skilled at thinking. Just because I can kick a ball with my foot does not mean I am a skilled football player. And just because my mind is working all day, that does not necessarily mean I am a broadly skilled thinker. So, since thinking is our occupation, research and writing and thinking is our occupation, we merely need to practice at it and to understand all the rules. And this is what I try to do with my courses. Now, how do you become skilled? You understand the game, you understand the rules, you accept coaching, not just once, but many, many times. You practice many, many times. You understand other people involved in the game. You understand your teammates, the referee, the opposing team. You have a strategy. And after you play a game, you think about the past game. You learn from the past performance and use that to improve your play for the next game. And it is the same thing with critical thinking. When we write a paper, when we do research, if it's published or if we fail to publish, we think about it, we learn, and we go forward to do better. So, if you want to become a skilled football player, you do all those things. If you want to become a skilled thinker and a skilled researcher, you think about it, you practice it, learn the rules and the procedure. Now, here is a definition of critical thinking. Thinking is a skill that can be learned, just like football is a skill that can be learned. Critical thinking is a process. An engineer can learn a process. A student can learn a process. Critical thinking is a process of purposeful, self-regulatory judgment that drives problem solving and decision making. I also say that critical thinking also drives the research process. In this process, one gives reasoned consideration to evidence, context, concepts, methods, and criteria. So there is a definition. It's a process of taking evidence and information and making decisions with a method that means we regulate ourselves. We drive ourselves. I believe that Heider has mentioned this specific model. It is put forth in the United States by Dr. Richard Paul and Dr. Linda Elder. For critical thinking, there are 8 elements of thought. All thinking has a broad purpose. I am a chemical engineer, and I am doing research of the sort that I think is of broad interest to chemical engineering and to people who benefit from chemical engineering. When I do a research project or write a paper, I have specific questions in mind. As engineers, sometimes we say that I have objectives or goals or aims to meet. These are other terms for having questions to answer. When I do research, I have existing information, and I also get new information from my laboratory and from my efforts. I then reason through that information to draw inferences. In a paper, we usually call these conclusions. There are important concepts in all of our research. In today's lecture, an important concept is critical thinking. In engineering research, another important concept might be a particular theory that one is working on. We make assumptions as we do our research. We may develop a theory and make assumptions to simplify the theory. We may make assumptions to simplify our calculations. We may make assumptions about the accuracy of our experimental apparatus. After we draw conclusions, we have implications. We do our research because we were trying to help others make important decisions. So if our conclusions help others draw implications or make decisions, that's what we want. And all of our research is done with a certain point of view. We have skills, we have experience, we have a theory that we like, we have other theories that we don't like, we have methods that we prefer, we may think other methods are not as good. We have a point of view about all these aspects of our research. Now, when I teach the process, I ask the students to learn to memorize these 8 elements of thought, and then I show them how those 8 elements of thought appear in a journal paper. I show them how those 8 elements of thought appear in a student thesis. I show them how those elements of thought appear in a lecture. And I try to train the students to read, to look for, to listen for those elements of thought. All very good researchers and all very good speakers address these 8 elements of thought in their speaking and in their writing. And I try to teach students to recognize these. Now, another important part of this model of critical thinking is standards. To think well, we must perform to high standards. The model suggests 9 standards for critical thinking. Relevance. For instance, I have done a piece of research. I want to publish it in a journal. The first question I ask myself is my research and my purpose and my questions, is it relevant to what the journal publishes? If I write a proposal to obtain money for my research, I ask myself, is the organization with the money interested in my research or not? If my work is relevant to the journal, good, I can probably publish. If my work is not relevant to them, I have to find another place. Very simple. Next is clarity. Are things clear? Is my writing clear? Is my figure clear? Are the words that I choose clear? Clarity, being clear, is a very important concept. There is breadth of research and depth of research. Just earlier this week, I reviewed a paper and I rejected the paper because their findings were extremely narrow. Their findings had little breadth, little depth of science, and I said, although the writing is clear, I could understand it. There was no breadth or depth to the contribution, and it was not worthy of publication. Fairness. This means, am I being fair to other researchers? When I cite their research and their meaning, am I being fair and balanced in how I treat prior work? It also means, am I treating my own data fairly? Am I being too generous with myself? Our data must be both precise and accurate. Our language needs to be precise and accurate when we speak and when we write. When we reason through data, we must be logical. And at the end, the research that we need must be significant. It must be important to someone. It must make a difference to the field. And so then, how do I teach? this process, how do I teach it? I ask the students to recall these standards and apply them to their self and their own work. I ask them to understand other people, the people who review the paper that you have written. They use these standards. The readers who are reading your paper, they seek relevance, they seek significance, they seek work that's breadth and depth, work that is clear to read. So students must understand that they must meet these standards. I have left you here this reference. I think that you will want to review this lecture and write this reference down. But you can go to this website. It was created by Dr. Paul and Dr. Elder. Dr. Paul and Dr. Elder. This particular site gives you a review of the elements of thought and the standards, and it is a very nice site to interact with, and it gives more explanation of the standards. So this is a very good resource for you. I look at this often myself. Now, I teach a course about using critical thinking to write a paper. How do you write a paper that shows sound critical thinking? How do you begin to write a paper that shows sound critical thinking? This is a figure that I show students. Over on the left, consider that new graduate students, like Hyder was at one time, new graduate students, they are in an airplane. They are 30,000 feet in the air. They are many kilometers away from their landing point. What is their landing point? Their landing point is they have prepared a good research manuscript and are ready to submit it to a journal for publication. They have worked well with their research advisor and their co-authors. They're ready to submit. As a teacher, my job is to teach students these skills, how to write a paper, and I try to take them partway to the landing. I am a chemical engineer. Hyder is an electrical engineer. I do not know very much about electrical engineering, but I know a little bit about engineering. I'm experienced. I know more about writing and publication. And so with Hyder or any other student, I can start here. I can help them understand their project. I can help them understand their advisor. I can help them understand the editor, the publisher. I can help them understand what makes a good paper. I can take them so close to the ground, and then they're ready to be turned over to their advisor and co-authors to finish the paper and submit it. So this is my job as a teacher. This is my job tonight with you, is to take you from this point part of the way to a landing, and you can continue on your own. Now, how do I teach writing? I develop tables like this one. I show them to the students, and I make them practice their writing using this table. So all research begins with a broad purpose. So the element of thought, let's start with element number one, the purpose. Here are some questions that one should think about when beginning to write their paper. These are guiding questions. What is the overarching aim of my research? What will be the ultimate significance of my research? How will my research benefit people? And I suggest try to state this in 1 or 2 or 3 sentences very specifically. Do not begin a paper by writing long paragraphs. Begin a paper by being very clear. In a few sentences, state your purpose. The purpose generally appears in the introduction of a paper, and oftentimes it is restated in the conclusions of a paper. All research is about a specific question or goals or objectives or aims or hypotheses. These are similar words that appear in a paper. And I encourage the students to think, what are my specific research questions, my specific hypothesis, my specific aim? And again, I suggest to the students, state these aims, number 1, number 2, number 3, number 4, very specifically. Review these with your advisor. Review these with your co-author. Review these with your fellow researchers. Make sure that you agree upon these. Don't write a lot. Write a few things very specifically. Get agreement, and then proceed. Now, these questions or hypotheses typically appear in the introduction to a paper, and again, they are often restated in the conclusion of the paper. And I have some more suggestions for writing. As you're writing the paper, remember your questions as you describe the method and materials, and as you describe the plan of your experiments. Remember these questions as you describe how you obtain information. And ask, do your approaches and your research plan, are they producing information that will answer your questions? Your approach to research must give information that answers your questions. And so we begin to see how these elements of thought are joined together in a paper and in a research program. Continuing, there are key concepts behind any research. Here are some questions that help you make sure that you explain key concepts. What are the main ideas, or the theories, or the principles on which your research is founded? Explain those in the paper. Are you introducing a new concept? Perhaps you need to define some terms. Make sure that you are using the right technical vocabulary. Hyder, I think, will understand this. Sometimes one can draw a picture to explain your concept rather than many words. Let me give you an example of a picture that helps explain concepts. It is this picture. I drew this picture to try to help explain my role as a teacher to help bring students from a starting point to the landing point. The landing point is a paper. The starting point is a brand new researcher. My role is to go this far. I think that that picture is clear. That picture, that graphic, helps explain some concepts. Now, concepts can appear anywhere in a paper, in the introduction, in the background, in the literature review. Perhaps you wait until the theory section to explain key concepts. So these key concepts must be explained at the right point in the paper. Now, here is the major portion of any research paper. It is the new information that's generated by your research. Also, in any paper, you begin by explaining what is already known. What is the accepted information from which your research project began? What is the current structure of knowledge upon which this paper is based? These are questions that help express your information. And then you ask, what new information have I generated? What new knowledge? What new capability is demonstrated in my paper? Some engineering research is very fundamental and theoretical. Some is very practical. Imagine that an electrical engineer has a project to build a robot that performs a complicated task. Then his paper is about demonstrating a new capability with a new robot. Now, here is my strong suggestion for students. When you have new information, before you start to write, spend a lot of time making the graphs excellent. If you present information in tables, make the tables excellent. The title, the headings, the numbers, make them clear, make them precise, make them accurate. Study them, review those, discuss the meaning with your research group, talk about your data a lot, talk extensively about your data, make notes. What do you see in that information? What does everyone else see? Make notes, then, and only then, start to do writing. Many times students start to write, and they write far too much before they have done critical thinking. They think that they should start by writing many, many sentences and paragraphs, and they have not thought. They have not looked at their data. They may take one experiment and look at it and start to write. No, don't do that. Okay. Information can be presented in the introduction or background. That's generally where you present the knowledge that others have created. And then you present your results in the results or discussion section of the paper. And most important, your new information and knowledge are compared with the existing knowledge and information. This is the major part of the paper. But I would maintain that students make a mistake by trying to write this part of the paper before they really have good agreement on what the purpose of their research really is and what their questions really are. I see this with new students. They spend far too much time thinking about what they just did in the lab and not truly understanding their project. Now, continuing, paper concludes. We have conclusions and inferences. Make sure that you state clearly what are the conclusions of this paper. I've read many papers and many reports where the student says, I did many things in the laboratory. I did many experiments. I generated much data. Here are the data. Then I ask, what do the data mean? What knowledge do you generate? What are your conclusions? What does it mean to me? And the student has done nothing but write a diary of their activity and never reached conclusions. I think in the United States, some professors tell their students to do the work in the lab. Bring me the data. And the professor says, I will decide what it means. Sometimes professors exclude their students from making conclusions and making decisions. Then when that student graduates, they have never learned to draw their own conclusions. They have never learned to be independent. Now, not all professors do this. Perhaps only a few professors do this. But it is important for our students to ask them, what do you conclude scientifically? What have you learned? And then with the professor and with the research group, you continue on that and come to agreement and finish the paper. Your conclusions, your results, your finding, when they are critically evaluated and when your results are compared with other knowledge, how does that make a larger and better picture of the knowledge structure in my field of chemical engineering, biomedical engineering, my field of energy research, my field of water research, whatever the field might be? Have I contributed knowledge in my field? And of course, these conclusions are stated at the end of the paper. One typically states conclusions and recommendations. Here's another thing. These do not always appear in a standard journal paper. But if we're doing important research, it means something to some decision maker somewhere at some time. So I asked myself, do the findings of this paper, do they agree with the other state of knowledge? If not, what is the correct knowledge structure? If my conclusions are accepted, what does it mean for future research? If my conclusions are accepted, how does it inform someone in government or someone in medicine? How does it inform someone else in the university to make a decision or to take an action? Students, if your advisor accepts your conclusions, what does that mean about the future of their research program? So understand that implications or consequences lead to possible future decisions. Having said all those things, there's not a thing I have said that is controversial. All of these things I think that I have said are obvious. When playing football, the object of the game is obvious. It is to kick the ball through the opponent's goal more times than you allow your opponent to kick the ball into your goal. That is very obvious. That is very simple. It almost not needs to be stated. But what does it need to play good football? You must practice, 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 coach, think, review, strategize, and learn from it. And so, even though this critical thinking model and its application may seem simple to you, I think most of you are professors and already very skilled thinkers. If we're trying to teach the process, we need to remember to our young students, these things are not so obvious. I know they're not obvious because I am an experienced research professor, having taught many students who are all more brilliant than me, but they have not learned to be good thinkers and good writers yet. When we write a paper, there is a point of view. By this, I mean a paper may be an experimental point of view. There may be a favorite theory, a theoretical point of view. A paper may be both experimental and theoretical. A paper may be very fundamental. It may be a very long-range research with high risk. There are people in this world trying to work on nuclear fusion to create electricity. That is a very long-range project, very high risk, very fundamental, but important. A project may be very applied. Someone may have a project to build a robot to do a task. A project may be driven mostly just to generate knowledge. A project may be driven because I need something right now. Much medical research is driven because I have a need right now. There is much research going on to find a vaccine for COVID because we need it right now. Research may or may not consider other factors. Engineering research has economic meaning. It may have meaning for the environment. Our research may have meaning for social policy decisions. It may have meaning for domestic or international decisions. So our research may or may not be driven by these things, but there is a point of view. And then finally, assumptions. What assumptions have gone into designing the apparatus and the instruments? What is the precision and accuracy of my instruments? Have I made simplifications to arrive at the theory? Have I made assumptions about the materials that I use? In chemical engineering, we buy chemicals and we state that the purity was 99% as told to me by the supplier. I assume that that is true. I usually do not check to see whether the chemicals are 99% sure. I assume that what the manufacturer told me is true. Usually it is true. Sometimes it is not true. So these are very, and there are many, many other questions to ask, but this is what assumptions means when a person is doing research. This is how you understand this element of thinking, assumptions. Ask yourself these questions. So, some suggestions when you are working with co-authors. Agree upon a very brief and concise statement of your purpose and your questions. Agree upon that early. You may not have questions, you may have aims or objectives or goals or hypotheses, but make sure that you and your co-authors agree upon these things. It is sometimes a case that an individual will go to work in the lab and do a great deal of work and then come back to find they're working on something that is not the objective of the project. Prepare and examine your information, your graphs, tables, photographs, your information. Agree upon the meaning before you start to write very much. Study that. Agree upon a concise statement of the conclusions, your findings, your new knowledge. What is the answer to your questions? Agree upon that. Then you can start to write a longer paper and continue working on it until it is finished. Now, there is another part of the critical thinking model of Dr. Paul and Dr. Elder. This is very important. All good thinkers as individuals have some universal traits, some universal habits of mind, some universal habits of character. All good critical thinkers practice intellectual empathy. Intellectual empathy. Empathy means understanding other people. Just as when I play football, I need to understand my coach. I need to understand the referee. I need to understand my opponents so that I can succeed and win. In doing research and in publishing, you must understand the reviewers, their job, the way that they think. You must understand the journal editor. You must understand the people who are trying to read your paper. That is intellectual empathy. Now, it does not mean that you have to agree with the reviewers. It does not mean that you have to agree with the editors. Sometimes people will criticize your research. They may be correct. They might be incorrect, but you must understand why they criticize your research. You must understand why they criticize or reject your paper so that you can improve it and try to get it published. Intellectual empathy. Intellectual humility. It means you must accept and use criticism constructively. When I played a sport, my coach yelled all the time. Our coaches criticized all the time because they wanted us to play better. They wanted us to win. When I write a paper or a proposal that is rejected, my feelings are hurt. I don't like to look at the reviews. But I have to make myself be strong, accept that criticism, and use it to be better. Good critical thinkers learn from failure and go forward. Good critical thinkers must also have intellectual courage. Sometimes you may be criticized. Sometimes someone may disagree with you. But if you are convinced scientifically that you are correct, defend your position. Now, try to write more clearly, try to write more precisely, try to show more breadth and depth of thinking, try to show more information, try to show more information clearly, improve your writing and your thinking, but have courage. If you are correct and you have improved your position, defend it and keep going. Don't quit. That's very important. That is very important for students in the university because sometimes they make mistakes. Sometimes the work in the lab does not work the first time. Sometimes the equipment breaks. They get discouraged. They have to have courage to keep going. And students especially must have confidence in reason. They must believe that they can trust sound research methods. They can trust good data. They can trust good approaches. They can trust logical reasoning. Students must believe. They must have confidence that they can trust critical thinking. I will stop with two pictures. Why do we do research? Let's look at this building. This is a nice building. It's well built. The building has use. Pretend that this building is some knowledge. It's some knowledge about a field of electrical engineering or mathematics or chemistry. There's a building. That's what we know now. Why do we do research? We do research. This is the same building. We do research because now, look at this building. It has been refreshed. It has been rebuilt. It looks nicer. It functions better. It is more useful. There's that new building. And look at what else we have done with research. We have added new knowledge. Not only have we refreshed and strengthened the existing knowledge structure, we have built new levels of knowledge on top of it. This is why we do research, to strengthen the existing knowledge structure and to add new knowledge, new directions, and new abilities. That is the conclusion of my talk. I thank you very much for your attention. I thank you again for the invitation. Dr. Hyder, I will return the floor to you.
Thank you, Professor. Really, for me, it is outstanding lecture. I learn a lot from you, and probably my people, they have a few questions, but I would like to say you make us to think more clearly, and I believe we are more good thinker. I learn at least from this lecture and from your courses, the 8 elements of thought. I said it for you, and I can say it very clear now. I took many courses in university, but as a researcher, your courses is the best courses I get it from you.
That is very kind and high praise from you. I appreciate that very much. Thank you.
Thank you very much, Professor. And let me see if some of our people, maybe they want question. I'm going to open Q&A. So if you have a question, please type it over there. Professor, one question I have in mind while I prepare for the other question. So the idea to bring a critical thinking to graduate students, as you said, the graduate students, they're supposed to be very knowledgeable, they work very hard. But you mentioned you are a very good observer. You see some students, even they work very hard, but they miss like the purpose, they miss the object, which is the same exactly for me. I am working very hard for 2 years, but after I took your classes, I wrote 3 chapters, like introductions, literature review, and I wrote a paper. And the reason why, because you make me clear, I think more clear, why you bring the critical thinking in this area.
Very good. You asked why do I teach critical thinking? I teach it because for many, many years, I grew frustrated by trying to write papers with my students. I grew frustrated with myself because I wrote proposals that were not funded. I understood them. I came to realize I did not truly understand the other people. I did not have intellectual empathy with the reviewers. And I don't remember when I discovered this model of critical thinking. I don't remember when, but I read it, I looked at it, and it became obvious to me very quickly. This is a process I can learn. It is a process I should follow to try to communicate with people. The elements of thought are the elements of a paper. It's just a different way of thinking about it, and it gives a person a structure, a consistent structure to write with. I've been interested in writing and language for a very, very long time. I have an older sister who is very smart. She wrote a very interesting paper in high school. I read her very interesting paper, and ever since then I have been interested in language and communication. But it was not until I discovered this model that I found a way to be consistent about coaching students.
Yeah, the beauty here, the coaching students, I think also you mentioned mentoring process, and which is totally different from teaching stuff.
Yes.
Yeah.
So let me tell.
Yeah. I would like to hear some question from our audience, Professor, if you don't mind. So guys راح افتح الميكروفون، فجميع اتمنى انه يكون ميوت، واللي يحب يشارك يسوي لنفسه انا ميوت. I have a question here, one from audience. He said, is critical thinking different in quantifications and qualifications method?
Yes. Critical thinking is the large structure that could encompass both quantitative and qualitative methods. Critical thinking should help one no matter the sort of subject that they do. So one of the elements of thought is information. Information can be either quantitative or qualitative. Some of you may do research in social sciences. Much social science research is qualitative. I have done qualitative research, but I can still think critically about it. So quantitative and qualitative are two different kinds of data, but critical thinking will enable both sorts of research.
Okay, here is a very good question, I guess. Say, what is the criteria for measuring critical thinking? I would say, for some students, they graduate, they cannot see their object or probably their purpose. They need to see it very clearly. If I answer them, Professor, can you?
Would you state the question again, please?
What is the criteria for measuring critical thinking? Like you mentioned, many students, graduate students, they graduate even because they do what the advisor told them.
There are two answers to that question. First, if you look at the papers that a student writes, if you look at the defense that they make when they graduate, you ask, has the student asked sound questions? Has the student logically, clearly answered those questions with precision, accuracy, breadth, and depth? So first, you listen to the student's research and do they understand it? But here is another very important criteria for critical thinking. Can that student leave the professor leave the university and then go on to ask their own questions? Can that student go on and then quickly become independent? Does that student have the intellectual courage to ask questions? Is that student have the intellectual confidence to go on their own? If a student is independent, confident, strong, and ready to be free from their advisor, then they've learned to be a good critical thinker. If that student depends upon someone else to tell them the questions, to tell them what to do, then that student is not yet a good critical thinker.
Thank you, Professor. I think it was perfect, I guess.
I see other good questions.
Yes, go ahead, Professor, if you don't mind.
Someone says, I still feel I am unable to do a perfect research. What should I do? What is my opinion? Let me first say, no research is perfect.
Yeah, that's good.
But it needs to be good. Now, you will know when your research is good when you get it published. That is part of the answer. Even published research is not perfect, but all research moves in small steps, small pieces. When you understand the previous knowledge and you feel confident, I have added a little bit. I have started with previous knowledge, but I have added a little bit. Then you have done good research. But don't expect to do perfect research. No one is perfect. Dr. Hayter, can you see my video?
Yes.
Good, because I'm moving my hands to try to illustrate.
Yeah, I like it when you say there is no
Very good.
There is no
nothing
perfect research.
I would also say have confidence. Do what you know is right. Talk with your advisor. Talk with your authors. I don't do things perfectly. We have meetings. We have committees. We have discussions about a question. We get everyone's input, and then sometimes collectively we make a decision. A researcher is usually not working alone. They're working with some others. Get their help, get their input, get their correction, and go forward. A star athlete is not perfect. A star athlete gets criticism from their coaches from time to time. And they take that criticism, they use it, and that's how they become a star.
So,
okay. Other questions?
So probably we're going to have 10 minutes more and we will close our session. Please, if you have questions, go ahead.
I see a question that says, how do we keep improving our skills of critical thinking? Well, if I had these tables to give you, I would just give you and say, practice them. Practice, continue to do research, continue to write your paper, and continue to deliver lectures. After a time, the reviews of your papers should become more favorable. They will never be perfect. After a time, it should be easier for you to get your paper published. After a time, people may start inviting you to give a lecture. But you have to remember every time to practice critical thinking. At the beginning of this talk, I put up a slide with my purpose and my question and my information. I had to remind myself even today, let me outline my lecture with a critical thinking outline. So I just have to remember to do it. Just like I have to remember the rules of football. I can't ever forget them. I have to warm up before every game.
Here is probably also another question. He said, one of my colleagues, he said, how can graduate students improve critical thinking? Because, you know, I took your classes, but what is your advice for one thing I would like to get out from this lecture? I would like, probably we can build a bridge with our university in Iraq to teach these classes. But if we don't get this chance, what is your advice for our people, because you see, we have different levels here. We have professors, we have graduate students. How to improve?
Well, so this lecture was recorded. I think it will be available to you.
Yeah.
I gave you a website. There is a great deal of information at that website to explain and to illustrate critical thinking. Now, most of that website does not deal with engineering and technical research. I hope one day to write a little book about this model of critical thinking and how to apply it to engineering and technical research. But until then, look at the website, look at the information. What I try to give my students is I give them a template, a guide, and I tell them start doing your first writing in that template. Just like the table I showed in the lecture, you could make that table, make empty spots, and start writing in that and use it. It's a different way to outline your thinking. It's a different way to outline your thoughts. It's a different way to see how a journal paper comes together, and just practice with it.
Yes, I would say one thing like empower me to get my PhD, which is very simple technique you give us the template, professor, if you remember. Like write your purpose, write your goals, your questions. This is even it is very simple, but it's very powerful for me.
Here is another thing for students. Sometimes, as you do research, the purpose will change somewhat. Sometimes, as you do research, you discover things, you see things, and the questions may change. So you should understand that research projects can change direction over time. I remember one of my advisors for my master's degree. I took him a plan to complete my master's degree. And he said, Mike, thank you. This is a good plan. Work on your plan, but I want you to understand sometimes things change and you may have to modify your plan. My first research project as a master's student failed. I observed something that meant all my data were invalid. I had to find a new master's project. I had to completely remake a new plan and do a new project. That happens sometimes. I hope it does not happen to you. It happened to me. It was a very difficult time. But understand that plans change, questions change. You may get a review of your article that asks a question or makes a point, and you may look at your research and say, there is something new and different in my research that I did not see, but the reviewer asked me to think about it, and now I have something new and different that I never even knew about until the reviewer asked me to think about something. Sometimes that will happen.
I got you, Professor.
Is there a difference between field research and paper research in terms of critical thinking? No. There is a great deal of difference in the methods and the tools and the skills, but there is no difference in thinking critically about different kinds of research.
Professor, here beautiful question actually, and you teach us always to you encourage us to take the critical thinking to our life. Here the question say, let me, if I can we take the critical thinking to another field or in our life?
I hope that my students and myself will think critically about other issues. There are issues in the United States that we make decisions about, that we vote upon. All citizens should think critically. I use another illustration. I am of an age that one day I should retire. I need to think critically about what retirement means. I have questions about retirement that I need to answer. I need to find information about retirement. When I find that information and I have a plan for retirement, I need to look at that plan and ask myself, what does that plan mean? Is that the plan that I want to use for my retirement, or do I want to start over again and rethink the issue of retirement? Retirement planning is much easier than doing research, by the way. But yes, should think critically about any important purpose.
That's cool. I would like to say thank you a lot, Professor, for your times, and I hope our message is clear for our college and we get the benefit from these lectures. And I have my deans also and the president of our university all join us, but for some reason I couldn't find them. In the name of them, I would like to say, and also in the name of my university, I would like to say thank you very much for your outstanding lectures, and hopefully we can do more in the futures, and really appreciate your time.
It would be my pleasure to work with you again. I'm very honored by the invitation, and thanks to you all for attending.
Thank you very much.
Good night.
اخوان الاعزاء اللي حاب اللينك مال الليكتشرز ممكن اشارك وياه بعدين، بس خليني اسوي الشير للايميل